All right, this is problem 54 on page 98. In the next video, actually I'll do problem 55, and they're sort of, maybe you should look at together with problem 46, problem 54, and problem 55 that I've done. These are to help you do problems 47 and problems 48 on page 198. In the previous problem, we were given a rational function, and it was a rational function which had the same degree of polynomial on it in its numerator and its denominator. And in that case, you'll find that you will get horizontal asymptotes. In this particular case, the degree of the top is 2. Yeah? The leading term of the polynomial on the top is 2. And the degree of the bottom is 1. Leading term is x as an exponent of 1. So if we run back over to page 194, and we look at this case that says if the top is 1 more than the bottom, the degree of the numerator is 1 more than the degree of the denominator, the line y equals ax plus b is an oblique asymptote. So this is a sure sign when the degree of the top is 1 more than that of the bottom. What results is an oblique asymptote. And quite simple to find that asymptote. Unfortunately, it involves one of my least favorite things to do, which is polynomial division. But you know, I get paid to do this, so I suppose I'll run through this. Let's take the bottom and let's divide it into the top. So I'm just going to set this up as a division problem. I'm going to note that I've got the x squared, the x, and the x to the 0 term represented here. I don't have to do anything else. I'm ready to go. So I'm just going to ask, what is it that I need to multiply 4x by to get 8x squared? And the answer is 2x. I'm going to write down an 8x squared here. I'm going to multiply this term by that. I'm going to subtract these. I'm going to get 0. I'm going to get 26x minus a minus 2x is 28x. And I'm going to bring down the 7. And I'm finished with that iteration. And I'm going to do this again. I'm going to put a 7 right here because 7 times 4x is 28x. And 7 times minus 1 is minus 7. And there you have it. This is a little bit of a strange case because I didn't recognize that 4x minus 1 actually divides into this top. So what we have is r sub x is actually 4x minus 1 times 2x plus 7, all divided by 4x minus 1. So this is a little bit of a strange case because r sub x reduces to 2x plus 7 provided x does not equal 1/4. Because if x equals 1/4, basically x equals 1/4 is not in the domain of r sub x. So if we consider all other values of x except for x equals 1/4, which happens to make the denominator 0, then r sub x, not only does it have an oblique asymptote of 2x plus 7, but its graph is 2x plus 7. If I plot this very quickly, r sub x, as well you know, rational functions, better put this someplace else that you can see it, so I'm going to tuck it right over here in this corner. As well you know, rational functions can have very wild behavior, but in this case, this reduces to a problem that is a line that looks something like this. It's got a slope of 2 and it's got an x-intercept of 7, slope 2. It has one other feature, and that is right there, it has a little hole at x equals 1/4. So So this problem fooled me a little bit. I didn't recognize that we had this special case, but one way or the other, you would proceed in just the way we did. As soon as you see that the top has a degree of 1 more than the bottom, the top is a third order, the bottom is a second order. The top is a fourth order, the bottom is a third order. The top, in this case, is a second order, the bottom is a first order. When that's the case, the rational function will have a oblique asymptote, and you'll find it by doing division, and you will find generally what you'll find is when you do the division, you'll get, I want to write plus R0 there, that's what I want to write. You can do it so that you can read it. When you do this division, you'll get a AX plus B plus a remainder. In this case, a remainder is 0. But the asymptote, the oblique asymptote, is this term right here. All right, on to the next problem.